Now how do I find E1 tilde? How do I find E1 tilde? E1 tilde is also a vector. It's a one form, but it's in the vector space. So I can think of writing this as some A times E1 plus B times E2. Now I require this E1 tilde comma E1 to be 1. Correct? This implies A times, so if I write this A times E1, which is basically 4, plus B times E to E1. What is E to E1? E to E1 is 2 times B root 2. So this should be equal to 1. This is one equation. The second equation is E tilde of 1 comma E2 should be 0. This is the definition of this one form basis. This implies A times root 2 plus B is equal to 0. So this gives you your B can be written as minus A root 2. That implies 4A plus 2A minus 2A is equal to 1. A is equal to 1 by 2. A is equal to 1 by 2 and B is equal to minus 1 by root 2. So if I write that way, so I can write this as 1 by 2 E1 minus 1 by root 2 E2. Similarly, you can get the result in terms of E2 also. So E2 can also be written in this way. E2 comma E1 will be 0 and E1 E2 comma E2 is 1. So let me see if there is a full way to basically, maybe we can use a little bit geometry here to visualize. So A is like this and B is like this. This is E1 and this is E2. Okay, now E1 tilde should be perpendicular to this. So it will be like this. And E2 tilde should be perpendicular to this. Sorry. E1 is perpendicular to E2, so this is something like this. This is E1, and this is perpendicular to E1. E2 tilde. Okay, this is of course correct way to do it, but let me just simplify this by, so this is.
But sir, the output probability is which two things? You have a drop perpendicular that side also.
Yeah, let's have only one sense in which it is perpendicular. But I think it doesn't matter otherwise. So the magnitude of this E1, okay, so E1 dot E1 should be 1. Okay, so what should be the magnitude? So if I say E tilde 1 dot E1 should be 1. E1 has got a magnitude. This implies, now what is the angle between E1 and E1? This is 45 plus 90, is 90 plus 45, right? So 90 plus 45, so this is nothing but E tilde 1 magnitude, E1 magnitude into cos pi by 2 plus pi by 4. Cos pi by 2 plus pi by 4 is minus sin pi by 4. So minus sin pi by 4 is minus 1 by root 2. Now E1 is already known, that is 2. And this has to be equal to 1. So we can immediately show that E1 tilde is equal to minus 1 by root 2. E1 tilde is equal to minus 1 by root 2. And similarly you can show E2. E2 to E2 is 90 minus sine. So this angle is 90. So E2 modulus E2 cos pi by 2 minus pi by 2. This is sin pi by 4, correct? So this should be equal to 1. So this is E tilde 2, this is 1, and this is 1 by root 2. This implies E tilde 2 modulus is root 2. So we have, you could have actually used this, but this is a little bit lengthy procedure, so I used the geometry to get the magnitudes, because by knowing the magnitudes we were able to get the metric tensor. So what I have shown here is so from geometry we can show that E tilde 1 magnitude is minus 1 by root 2 and E tilde 2 magnitude is root 2. Now once we know this, we can write down the metric tensor G11 is equal to mod E tilde 1 square, that is equal to 1 by 2. G12 is equal to mod E tilde 1 mod E tilde 2 into cos of, what is the angle between E tilde 1 and E tilde 2? This is 90 degrees to this is 90 degrees to this. So this is also pi by 4, right? So this is pi by 4. So we will have cos pi by 4. So that is equal to minus 1 by root 2 into root 2, that is E2 into 1 by root 2. So you will have minus 1 by root 2, which is also equal to G21. Which is also equal to G21. And G22 finally is equal to E tilde 2, E tilde 2, that is equal to 2, because E tilde 2 modulus E is root 2. So we have the inverse of a metric tensor is equal to 1 by 2 minus 1 by root 2 minus 1 by root 2 and 2. You can see that they are different, and you will find them different in non-orthogonal basis. Now you can ask a question here. I did not write. Is this the inverse of this matrix? That question one can ask. Suppose if you treat this as a 2 by 2 matrix, and I ask what is the inverse of this matrix, the determinant of this matrix, determinant of G is 2, and the inverse of this matrix is equal to 1 by 2, 1 by determinant times, how do you write? If you have a matrix A, B, C, D, at least the 2 by 2 matrix, it is very easy to write, is 1 by AD minus BC, that is a determinant, DA minus B minus C, correct? That's the inverse of this matrix. So essentially, each of this becomes the cofactor matrix of the other. You take the cofactor and take the adjoint of the cofactor matrix, you will get this. So this is 1, this is 4, and this is minus root 2 and minus root 2. And when you do this, you will get half minus 1 by root 2 minus 1 by root 2. So that is the same matrix. So if you take two one forms and then define a metric tensor, you will get the inverse of the metric tensor. Okay? So essentially, a vector will be transformed into one form by a metric tensor, and a one form will be transformed to a vector by an inverse metric tensor. And usually we say this one with G alpha beta. These components are referred to as G alpha beta, and these components are referred to as G alpha beta. We can also talk about mixed metric tensor. Mixed metric tensor, for example, G11. How do we get G11? You take the 1, magnitude of 1, and magnitude of 1. Magnitude of 1 and magnitude of 1. And of course, you have to talk about cos of the angle between that. So let us keep this diagram here. Let's say this is E1 and this is E2, and this is E1 tilde, this is E2 tilde. So what is the angle between E1 and E1? 90 plus pi by 4, correct? Oh, I do not have to. Okay, by definition, this is 1, correct? E tilde 1, E1, by definition is 1, because we define those basis vectors like that. And similarly, so it is easy now to write this G vector in the mixed form. This is always 1, 0, 0, 1. In the mixed metric tensor is always 1, 0, 0, 1. Okay, this is a simple example. Is there any question in this? Do you understand how to do these operations?
That vector diagram should be different from that mixed tensor.
See, the mixed tensor is not a dot product like this. Okay, it's not E1 modulus E1 cos of the angle between them. It is defined that E1 dot E1 is equal to 1. Okay, so that's the definition of how do we define the dual basis vectors. We define them with this E tilde alpha comma E beta is equal to delta alpha, right? So if alpha is equal to beta, it is 1. If alpha is different from beta, it is 0. So maybe what you are asking is something like this. Suppose if I write E1 tilde 1 modulus and E1 modulus and cos pi by 2 plus pi by 4. Okay, so this E1 tilde 1, what is that? That is minus 1 by root 2. And E1 is 2, and this is sine pi by 4, which is minus 1 by root 2. So you will get this to be 1 anyway. But I am saying we don't have to check this, because by definition E1 A1 is equal to 1. So same diagram can be used, but we don't have to do that, because by definition the basis vectors corresponding to dual space are orthogonal to basis vectors corresponding to vector space. So we can use this definition to say this mixed tensor is like this.